5 times 5 is?
25.
Yeah. Hey folks, welcome out there this afternoon to Tea and Learn Mathline. Summer school running rampant here. Well, almost. That's going to be next week. But for many of us, we are out of school and you are tuned in and just enjoying the day, I hope. Hope you had a great summer so far. And we'll be back next week with summer school going full force for 9 weeks. We want to be sure to plug that and remind you. This is a specialized segments today, which means simply you don't have to call in because no one's going to be there to answer, but you still can send us messages on Facebook. You can also send us through our email address, and we have time at the end. We'll tell you about that also. But anyway, you know the drill. Get you some paper, get some pencil. You'll probably want a graphing calculator on this one with you to really sit back, relax, and enjoy this one. And before I forget, I want to thank the Bearden High School students from an AP Statistics class. They're helping us with some of the questions today. So let's find out what this is all about today. Just check out our topic, growing like a weed. Growing like a weed. Now that doesn't mean we're going to do linear growth, which means we're going to add the same thing like every month or things like that see a constant rate. We're looking for exponential growth today because that really is when you grow like a weed. Crazy how that takes off after a short time, and then the longer it stays in, the more and more it accelerates. Ooh, it's awesome. It's awesome. Exponential growth, all right? So let's talk about what it looks like. So let's take a look at the formula, first of all, that we're going to be working with today, all right? The formula is, we start off with A. We got some letters here, and we want to explain what these are going to be representing. We start off with a big A right there, and I'm going to use the letter P. Most people use that. That's going to be our starting point. And then we have 1, and we have to add a rate to that. If it's going to grow, it's got to have a rate added, all right? Otherwise, it's just going to flatline at 1. And you say, why is it going to flatline? Because we're going to raise it exponentially. There's that exponential part, okay? Now, what do these letters stand for? They were nice. There's a nice one. I give you a formula, but let's understand what it is. A likes to say for the amount of money, people, whatever we're going to end up with here, whatever our starting point is, that's going to be that plus the increase, all right? Whatever we get for an increase plus this P is what A is going to be worth, all right? Now, T is the time, and it's going to be based pretty much on whatever the period is that we set up. If it's set up for annually, it's going to be the number of years. If it's set up for quarterly or semi-annually, things like that, that's going to be based on the periods, the number of periods that you're actually using over those years. So watch out, we're going to have one like that. We'll see that at the end of the show. And the R, it's the rate. It's the rate. And it's going to be in a percent form to begin with, so you've got to make sure you change that percent to a decimal, all right? And as I said, P, principle. Where do we start? Where do we start, all right? And that's the story of exponential growth. Formula, all right? It's a powerful formula. Banks use it. House payments use it. Automobile dealers use it. Everybody got to know about growth, you know, because you're going to got to make money, all right? And interest is such a big deal there. But populations also. Let's take a look at a population situation, all right? It says the school has 1,000 students enrolled and expects to have an average 2% growth rate each of the next 5 years. Each of the next 5 years. Wow. How many students are expected to be enrolled at the end of 5 years? And we're going to talk a little bit about some semantics here at the very end, but for right now, here's what's important. We got 1,000, we've got a rate, we've got a time. And you know what? We have a formula. A equals P times, how about it? 1 plus R and our exponent T, all right? Now, as I said, A is what we're going to be looking for. That's going to be the new total, all right? And basically, we'll look at this piece by piece, all right? But at this point, what we do know, everybody with me out there, I hope, is that P is 1,000. That's your starting point, all right? The principle, point of beginning, all right? That kind of thing. Anything you want to let P stand for, that'll help you. Now, we're at 2%. We don't write plus 2. We'll have an amazing population if we write plus 2. We've got to change that percent to a decimal. So we're going to have 1 plus, remember, move it 2 places. That'll give us 2/100ths, 0.02 that you all love to use. And how much time? We're going to run it 5 years. Each period is going to be an increase of 2%. 2% of the next one, and again, and again, and again. So what happens is we're going to increase the first year, but then we're going to take 2% of what we have plus that increase, all right? So there's a percent of increase happening, and then another increase. So it kind of begins to snowball. That's what we call it exponential, all right? So let's see what's going to happen when we plug these numbers in. Let's go to the calculator to do that, all right? Because this gets rather complicated trying to do it by hand. So let's go to the calculator. We're going to type in 1,000. And there we go, 1,000 people. And it says we're going to take 1 plus 200. Well, you know what that's just simply glue them together. We get 1, as you all love to call it, 0.02. And we'll just close that parenthesis right there. We're going to raise it. So go for the exponent key. Let's see what happens 1 year. Let's just do 1 year first, all right? If I do it for 1 year, that's simply going to give us 1,020. Now, if I were to take that 1,020, and then I were to take my increase again, this time it's going to be still 1 and 2% added onto it, so 1.02. And this time we'll raise it again. 1 more year, because we've now taken the next one there. Oh, we get 100, we get 1,040 and a little extra there, all right? Now, that takes a long time. That takes a long time to do those things. So let's start over again, and let's just use the formula and see where it takes us, all right? But you get the idea. That's what we would be doing if we did it step by step. Whew, thank goodness for the formula. We have 1,000, and we're going to take that 1.02, and instead of taking forever, we're just going to go straight to the 5th year. And there it is, 1,104 and a little bit extra. So it looks like we increased from where we started. Looks like we've increased by about 104. Now you see that decimal part out there, 0.08? That's where we get a little kind of crazy here. Do we think that we need to bump it up to 1,105? Or do we stay at 1,104? All right, so let's talk about that one. Let's look at this. These are students now, by the way, so we can't have 800ths, excuse me, of a student. Okay, it doesn't work. I've never seen one of those, and neither have you all. So we've got that many students, or do we have 1,105? All right. Now, when we get money down here, when we start talking about interest, it's easy because it's dollars and cents. We just simply get to the nearest cent, we go. All right. But when it's people, you can't just take parts of them. All right. You may try it, but it just doesn't work very well. On this one, I would be saying that at the end of 5 years, you're going to be here. You've still got that extra one to pick up later. This is the one I would go with. I would say, but one student, you say, is there a big deal about that? Not really, not really. But if you're, if you've got to find a place to put them, a locker and all those other things might be important, okay, to know that difference there. But you try to plan ahead. That's what that problem is about. And that's kind of what we're going to be looking at today, all right? Things that grow, things that grow. Man, 104 student difference from when they started. So you got to plan ahead, got to plan ahead. Growth is inevitable in so many of our schools. Very important, very important. All right, now let's see. Bearden folks, you're going to help me out some today. So let's see what you've got coming my way. What kind of questions you got for me?
Got a math question? Mathline has answers. Hey, Mathline.
Hey Mathline, I'm Evan from Bearden High in Knoxville, Tennessee. If I invest $4,000 to be compounded annually at 4% for 5 years, how much money would I have in my account? Oh, and how much in interest?
Oh, Evan, thank you. From Bearden High School there. $4,000 compounded annually. So that means the interest upon interest upon interest. He's going to put it in for an average 4% for 5 years, all right? Wow, how much money will he have in his account? And then how much interest is he dead? Ooh, maybe make us have to think a little bit, but that is interesting to know because remember the formula we have gives us the final amount. So let's see what we've got here on this one, guys, all right? We have the formula. That's the best way to start, all right? And we're going to look for the amount we end up with that, what was it, $4,000 plus this rate of interest for 5 years. what kind of money we make. Now, we're not adding any money to it, all right? We're just starting with $4,000. We're going to see where we end up, all right? There's nothing to be added here except our interest upon interest upon interest. It's really good stuff, all right? So let's see. We've got 4,000 going in for the P slot. We have now 1 plus the rate. Remember, change that to a decimal, 0.04, 400ths. And it's going to run for 5 years. We did that for 5 years here. And you know what? Again, the best thing to do on this one is go to a calculator. This is one you don't want to try to crank out by hand. Or a computer. Computers do this wonderfully too. Let's go 4,000. And we'll put our parenthesis. This time he's given me a 4% chance. So here we go. And we're going to raise that to the 5th power because that's how many years he's going to leave that money alone. That means you don't touch it, you don't put anything else in, you don't take anything away. This is what you hopefully will be ending up with. Let's see what we got. Whew! Big money. And by the way, like I said, we're going to round off. We're going to round off to the nearest, let me get over there, to the nearest cent. So it looks like it's $4,866.61. That's what's in the account. That's what you have. Okay, so there you go, Evan. That's your money. What did you earn? What was the increase? Well, you started at what? 4,000. So let's look at interest. We'll call it I, like anything better to do. And we're going to take the amount you have now in the bank or in your account, whatever this happens to be, investment account, and we'll subtract 4,000. And in 5 years, you've made, just by leaving your money in there to be worked upon, $866 and a little bit of chump change, 61 cents. That's the interest you actually earned, all right? So a lot of times we look at this number, sometimes people say, my goodness, we earned that much in interest? No, this is the amount. Here is your interest, all right? So be sure we don't want to get that confused, and we certainly don't want to get people's hopes up. Again, notice here, had you put the wrong decimal place? Some of you might want to put 0.4. Boy, I wish it would go up that fast. It would be amazing how much money this would be making, churning out interest. But we're at not 40%, but 4%. So again, watch those things, watch your decimals. You guys know when you change from percent to a decimal, it moves 2 places. 2 places. No matter what you're looking at, that percent change to a decimal is a 2 decimal place bunch. All right? So let's get our next one here. We've got another one coming in from Bearden.
I'm Alyssa Grove from Bearden High School, and I have a problem for Mathline. Which pays more money into an account? $1,000 invested at 5% compounded annually for 10 years, or $800 invested at 4.5% compounded annually for 10 years?
All right, Alyssa, thank you. It says, which pays more money into an account? We're going to go a little deeper in that, because if you'll notice, we've got 2 things going here that are working in your favor. You're choosing between $1,000 at 5% compounded annually, 10 years, or $800 compounded annually at 4.5% for 10 years. Obviously, the time frames are the same. Now, it is important how much you start with initially. That's important. So 1,000 versus 800 will do something, as will those percents. So let's take a look at this, all right? Let's take a look at this. So 10 years, that's flat for both of them, all right? And folks, the more you can invest, if you've got a sure deal, the more you can invest, the better your return's going to be, all right? So that, first of all, gives me an indicator. Also, I've got a good deal going at 5% here versus 4.5%. Now, that's not, you said, Ernie, it's just 0.5%. What's the deal? Well, again, depending on what numbers we start with and what numbers you're going to run it through, we're all going to see what happens with 10. So let's run these 2 and see how much better it is going with 1,000 at 5%, all right, for 10 years on an annual basis, compounding annually. So let's check it out here. We've got it. We've got 1,000 times 1 plus, we got 5% on that one. And again, this time we're going for 10 years. Listen, that's a good thing to realize too. The longer you wait, folks, the more time you spend, that's your best friend. That is your best friend to get compound interest working. If you've got patience, It's good. It's very good. Let's check our other one out. That's going to be at 800. And here we want to make sure that we do decimals right. It is 1 plus and move it 2 places, folks. Places. You put 0.45 or 4,500 hundredths, you're going to be a big deal. This is 45 thousandths, all right? Because that's what 4.5% does for us, all right? Goes back to there. And we're still running to 10. We're going to go 10 years, all right? So let's see what the calculator gives us on this, all right? See what our totals are, what our accounts are going to earn. We started with 1,000. We are going up to add those together. We'll have 1.05. Raise it to the 10th power. So go exponential. And that power is what's powerful. No pun intended. I see, $1,628, and we're just going to go with 89 cents there. We're going to knock that off, all right? Now, let's go ahead and take the next one. Actually, yeah, let's go ahead and take that next one here. While we got it here, let's go 800 times, how about it, 1.045. And we're also going to go 10 years on this one, all right? So here we go. And this one comes out with $1,242 and looks like about 38 cents. Now, let's compare those two numbers. We got them side by side here. All right, we'll clear those off. And let's go back to my page here. Got them side by side. Look at that, money-wise. Starting off a little higher, we start off by 200, okay? We had a little bit less of a percent rate, 0.5% rate. But my friends, both of these made some difference, all right? You started off 200 apart. Look where we are now, almost 400 apart, almost 400 apart. So again, that principle to invest is a key ingredient, as well as just even 0.5% makes a difference, all right? And oh my goodness, those time frames, they're the big deals. They're the big deals. So obviously this one works better, but notice almost doubling your amounts. So good stuff there. Alyssa, thanks for that question, all right? We got another one coming? I believe we do.
Hey Ernie, I'm Marissa Noon from Bearden High School. What if my great-grandfather had a $500 investment 50 years ago that earned an average 4% interest compounded annually? How much would that investment be worth now?
Wow. 50 years ago, great-grandfather had a $500 investment, and all it did was earned 4%. We think that's just not much, but compounded annually for 50 years. What would it be worth now? Let's take a look at this one. Let's take a look at this one. We've seen lots of different amounts here today. Evan gave us 4,000. We had Alyssa giving us 1,500. Now Marissa is giving us just 500. Just 500. So let's see what happens though. I told you time can be one of your best friends. Let's see what happens to that $500. So again, the rate is 4%, 0.04, 400ths. This time we're putting a 50 up there. Wow, that's a high power exponent. Big one, a big one there. Let's see what we get on our calculator. It's going to make it. It's going to make it. Some of you said, well, can it handle that? Sure. It can do a lot of good things. Let's put that 1 and let's go with it. This is 400ths. And we're going to raise that to the 50th. Raise it to the 50th. Whoa! That amount, $3,553 and a little chump change, 34 cents. Whoa! Compared to 500. Folks, that's 7 times the investment. That's 7-fold, all right? You say, wow, Ernie, what did we add to it? Well, what did we add? We added 3,000 extra, all right? So you earned interest of 3,000 with a little bit extra. It looks like about $53.34. That's pretty powerful stuff. Then you say, I'm not going to be around if I started 50 years ago. He's probably, great-grandfather may be still alive, don't know. But leaving that kind of thing, time, as I said, time is your best friend. If it's a steady growth situation like bonds, stocks, they go up and down. But overall, they tend to seem to keep moving forward and forward. So when you do investment, look for things that have a steady growth rate. And when I mean steady growth rate, that means on the year, because you're going to get interest upon interest. And sometimes you want volatility, which is exciting, although it goes down occasionally. Patience, stay the course. 50 years is a long time, but obviously look at the payoff. Man, can you imagine what would happen if you put $5,000 in there? You can try that at home, all right, and see what happens if great-grandfather was even more willing to part with his money back then. There's no parting with it. It really works well. All right, great question. Thank you, Marissa. Marissa from Bearden High School, AP Statistics class. Thank you all for helping out. Got one more going, I believe, here.
I am Linus from Bearden High School and have a money question for you. If I have $5,000 to invest at 2.4%, compounded quarterly for 4 years, how much money would it be worth including interest at the end of the period?
Wow, Linus, thank you. You threw me a quarterly moment here versus annually, all right? So we got $5,000, so we're going to go back and use our formula, principal times 1 plus rate, and we're going to raise it to a T. We're going to have to do a little adjustments here, all right? So let's talk about that one, all right? So we're starting with $5,000. That's easy. You've got what looks like not an intense rate there, 2.4% rate, compounded quarterly for 4 years, all right? Now, quarterly, that means 4 times a year. So here's what happens. Here's what's happening. We don't get, folks, we are going to start with 5,000 here, all right? But what we have to do here is going to be 1 plus. We have to adjust our rate a little bit because that's an annual rate. That would be an annual rate, all right? So we need to take that and adjust it down divided by 4. So we're going to end up with, there's our decimal, 0.024, and we're going to divide it by 4. Now, the advantage is we're getting 4 times a year, and we're going to do that for 4 years. So we are going to have not t equals 4 this time, but we're going to take 16 because that's how many intervals. Remember I said earlier, most of the time we're talking about years here, but since we've broken this up into quarters, we're now saying 16 quarterly intervals for that to happen. And again, interest upon interest upon interest. So let's go to our quick calculator here in just a second. Let's get a little bit more written here. This becomes 1 plus 0.006, and we're going to raise that to the 16th power. All right, so notice we do have two zeros between the decimal and the 6. Be careful because, again, you will have an explosive amount of money. Wish you could, but won't be exactly right. So let's check the calculator out, see what happens here. I'm going to put in my 5,000, and we're going to multiply it by 1.006, and we're going to raise that to the 16th power. Again, that's our quarterly payments. And I'm getting, it looks like on this, after all that work, still pretty good. $5,502 and about 22 cents probably if they're good to you, all right? So let's take a look at that one. Let's take a look at that one. That means you got about $502 in your interest there, all right? So again, that would be the interest part. 5,000 is what you started with. Hey, Bearden folks, thank you so much for giving us those questions today. I thank Evan, Alyssa, Marissa, and Linus, and we are so glad to have you with us today. We'll have some more Bearden folks tomorrow because tomorrow we're going to look at the downside of this growth. We're going to call it exponential decay. And what happens is called depreciation. Unfortunately, it's a fact of life. Sometimes it's beneficial. As you get older, you'll find out that depreciation can help you on properties and things like that. But it's a fact of life. Things tend to lose value as they get older. So, hey, but things that don't lose value, TN Learn Mathline. And let's look at there. How can you touch base with us this year and this summer? How about it? Facebook, one way. Facebook, www.facebook.com. Also, we're going to be glad to take your emails, mathline@tnlearn.org. As always, we're here. Won't be having any local live call-ins this summer, but we are going to be available, and we'll address those questions on the air. We also have YouTube. You can catch us on there, www.youtube.com. Take the /, and it's great stuff. And, of course, like I said earlier, email. We love to get your email. Even in the summertime, we'll take care of you. Be sure to give us a return address on those emails should you send them over your phone. And you know what? It's been good to have you with us. Thanks again, Bearden High School and the AP Statistics class. That's a mouthful to say. Great job today. We've got 4 more of those coming tomorrow, and we're going to look at decay, exponential decay, and depreciation. Don't want to miss out on that. And then, you know what? It's summer school time. We're going to have a great time this summer for 9 weeks. That's 2 months and 1 week into August. And then, guess what? Live call-ins again. But for now, you take care. We'll see you soon.